When you think about math, it's easy to picture it as this finished thing, right? A book of problems that were all solved hundreds of years ago. But what if that's not true? What if math is actually this huge, unexplored territory? And what if we're on the verge of sending a totally new kind of explorer into that wilderness? One made of code instead of courage. And that, right there, is the million-dollar question. We all know AI is a beast at calculating, but can it actually discover something? Make that creative jump to find something genuinely new, something that actually pushes the frontiers of what we humans know. Well, that's the massive challenge researchers are tackling right now. So let's meet the star of our show today. It's a brand new AI system from Google DeepMind, and it's called AlphaEvolve. It was designed from the ground up for exactly this kind of exploration, and honestly, it's being talked about as a game changer for how we discover things in math. So how in the world does this thing work? Well, think of it like survival of the fittest. AlphaEvolve uses the wild creativity of a large language model to just brainstorm thousands and thousands of potential ideas. Then a super ruthless automated judge comes in and tests every single one. Only the absolute best ideas get to survive, evolve, and then create the next generation of even better ideas. And look, we need to be clear about this. This isn't just a small tweak or minor update. The people who built it are calling it a fundamental transformation. This is a whole new category of scientific tool. What's really wild is when you see just how much of an upgrade this is from the last version, which was called Fun Search. Just look at this comparison. It's not just tweaking little 10-line functions anymore. It's evolving entire programs with hundreds of lines of code. It's not locked into Python. It can use whatever language you throw at it. And maybe the craziest part, it's way more efficient, getting better results with just thousands of attempts instead of millions. But here's where it gets really, really clever. The true genius of AlphaEvolve, its secret weapon, isn't just about being bigger or faster. It's a totally different strategy. It's not just evolving the answer, it's evolving the method for finding the answer. This is the game-changing idea, and it is absolutely brilliant. Okay, imagine you want to bake the perfect cake. The old way would be to just bake a million different cakes, right? And just see which one tastes best. AlphaEvolve is way smarter. It doesn't evolve the cake, it evolves the recipe. It works on perfecting the instructions, which you can then use to go bake the best possible cake. So here's the play-by-play for how that actually works. It starts with a bunch of really simple search programs. Think of them as basic recipes. Then the LLM acts like a super creative chef, suggesting all these smart variations on those recipes. Each new recipe gets tested to see how good of a solution it finds. And of course, only the best ones survive to inspire the next round. It is literally survival of the fittest, but for algorithms. And that's the beauty of the whole system. You use the slow, expensive, but incredibly creative part, the LLM, to do what it does best. Design a really fast, really efficient search algorithm. And then you can take that algorithm and run it super cheaply to explore billions of possibilities. It's the perfect division of labor between pure creativity and raw computational muscle. Okay, so the theory sounds amazing, right? But the real question is, does it actually work in the wild? Well, the researchers put AlphaEvolve up against the ultimate test. They unleashed it on some of the most stubborn, long-standing problems in all of mathematics. And they didn't just cherry-pick a couple of easy ones. No, they tested it against a massive list of 67 open problems in really thorny fields like geometry and number theory. And get this, in most cases, it actually rediscovered the best solutions humans had ever found. And in a few key cases, it did even better. One of its biggest wins came on something called the Kakeya problem, which is a famously difficult puzzle in geometry. Here's what's so cool. AlphaEvolve didn't just find a better number. It discovered entirely new mathematical constructions. These are like complex geometric objects that gave human mathematicians a completely new angle to attack the problem from. And you have to hear this part. The AI's discovery was so new, so out of left field, that it directly inspired a brand new research paper by one of the world's greatest living mathematicians, the Fields medalist Terence Tao. Think about that. This wasn't just an AI finding an answer, it was an AI sparking brand new human creativity at the highest level. And the Kakeya problem wasn't a one-hit wonder. For the kissing numbers problem in 11 dimensions, which is basically a puzzle about how many balls you can pack around one central ball, it nudged the record up by one, from 592 to 593. For another super complex inequality problem, it tightened the known boundaries, inching us all closer to the final truth. So what does all of this mean? Is this the end of the road for human mathematicians? No, not at all. It's actually the opposite. This is the beginning of a powerful new kind of partnership, a new fellowship for discovery. The researchers were really clear about this. The absolute best results came from humans and AI working together. A mathematician's intuition helps frame the problem and guide the search. The AI then explores a universe of possibilities that no human could ever hope to cover in a lifetime. And then, the surprising things the AI finds feed back to the human, sparking new ideas. It's this beautiful, virtuous cycle of discovery. And this pipeline they built just shows you what the future looks like. They basically built a whole team of AIs. First, you've got AlphaEvolve, the explorer, finding a promising new path. Then you have another AI, the theorist, that figures out why that path works. And finally, you have a third AI, the auditor, which turns that theory into a rock-solid computer-verified proof. And that is a huge, huge deal. It's a workflow that takes you all the way from a creative hunch to a formally verified, indisputable mathematical fact. It's a completely new way of doing mathematics. I mean, this is clearly a massive leap forward, but it also makes you wonder, where do we go from here? What does the future of discovery even look like when you have tools like this? First, it's really important to remember that AlphaEvolve isn't some magic wand. It's incredible at certain kinds of problems, but it struggles with others. And funnily enough, that very limitation has sparked a fascinating new idea. The researchers have proposed a whole new category of problems, AlphaEvolve hard. These are the problems where even this incredibly powerful AI gets totally stuck. And by identifying them, we can actually map the true frontier of knowledge. We can see which challenges just need more computing power, and which ones, well, which ones require that special, uniquely human spark of insight. The AI is actually helping us understand its own limits, and that, in turn, is pointing the way for us humans. Which leaves us with this one last incredible thought. We've just seen an AI that doesn't just find answers, it evolves better ways of searching for them. It's become a creative partner, helping us uncover new truths about the universe. And that really begs the question, if we can evolve the search for truth in a field as abstract as math, what other great unknowns in medicine, in material science, in all of engineering are now, for the very first time, finally within our reach?